So the second problem that we'll be doing is of heat transfer. So as per the question, this is a fin which is insulated on the perimeter. So what that means is heat transfer through convection is not possible in this. Then the left end temperature is 100 degrees Celsius, which is a boundary condition. And on the right hand side is the flux of 5000 watt per meter square. So this is a loading condition. And thermal conductivity is 6 watt per meter degree Celsius, and the cross sectional area and length is as follows. So now this time the goal is to determine the temperature at following positions, which can be interpreted as different nodes, right? So like if you go to the solution, we'll see that there are 4 elements, and then there are 4 plus 1, 5 nodes. So yeah, so we can interpret this as 5 nodes, 4 elements meshing. So yeah, we'll move on to the abacus. Again, the starting UI is like this. We'll start with standard explicit model, and for ease of access, we'll change the work directory again to D and FEA project. Okay, okay, and we'll save this file as second problem heat transfer, so that the second user is able to understand what it is about. So the model database has been saved. You can see as follows. So we can see that this is again a 1D problem. We can approximate it as a 1D problem. So 1D or 2D per se, because I am saying 2D, but then again I'll choose wire. So that will convert into a 1D. Then we'll assign section. That is something we'll do later on. First, okay, these are the settings. Approximate sizes to where. Why? Because you can see this is 0.4. So we need to experiment with this scale factor so that we are able to see it on the screen. We set it as 2 and take the line tool, initial coordinate as 0 comma 0, enter, then 0.4 comma 0, x comma y, then enter. That is the line. See, if I had 1000 as a scaling factor, the line would be very, very small. That's why I did 2 across and done. This is our line. Next, we change the module to properties. Then either you can click on create material, or you can click on material manager. It's one and the same thing. So I'll click on create material. This time we have thermal properties conductivity as 6. Okay, so we'll type 6 and okay, that's it. Our property has been created. Now we'll create a section. We'll go to beam and truss. Okay, this is a 2D wire problem. We'll do beam and truss. Continue, and here we need to assign section. Section area is 0.1. So we keep as it is. One material is 1. I didn't change material name, but it is material 1. Okay. Now assign that section to this line. So now it is saying select the region to be assigned. We'll just click on the line and just click done. It will tell you only one section is possible in this list. So 1, and click on OK. The section has been assigned. This is green color. Now we are done with this module. We'll go to assembly. Again, this is a step that we must perform. So yeah, we have done that. Now go to step, go to create step, and this is a heat transfer problem. So we'll try and change to heat transfer. Continue, and this is a steady state problem because things are not changing with respect to time. So steady state. Again, this incrementation, you can keep it default or you can do 1 and 1. That doesn't matter. This time let's say I'll keep it default. So I'll do cancel and no change. So I'll again create heat transfer. Only change this to steady state. Dismiss this and okay. Nothing else here. Go to load now. No interaction here, only loads. In load, first we'll put the boundary condition. In boundary condition, we can define the temperature. Okay. So we'll define the temperature and continue. We'll define temperature at this point. Then, and it's 100 degrees Celsius. So we'll just put 100. Okay. So that has been defined. Now we'll put the loads. Now here the load is not surface. It's a 1D line, right? So it will be a concentrated heat flux. Because if you even if you select surface, you won't be able to select a point or a region because there's no surface. So we'll go concentrated heat flux so that we can select a point, and we'll click on this point. Now here we need to fill the magnitude. So here it's not straightforward. Okay, so here given us 500 watt per meter square, that is flux. It's not load. So we need to multiply this by area. So that gives us 500 watt, right? So that is the load. That is 500 watt per meter square is not the load, it's a flux. Okay, make sure that you enter 500 here and just click on OK. So you will see that it has been done. Our next step is mesh. In this, like you might remember in problem 1, we did partition, so we did not have to do multiple elements. So here we did not do partition, so again same, we'll switch it to part. In this we'll select the edge. So yeah, partition was not there, so we'll have 4 number of elements. So it will create 4 elements. Now we have created elements, we'll mesh it. Oh, before meshing, make sure that you assign the element type. Here it's not a structural static problem, it's a heat transfer problem. So we'll go to the family heat transfer and just click OK. That is done. Now we will mesh it. Click yes. 4 elements have been generated. So now what you have done is you have made a line, you have created a section, you have assigned the material with the section, and then you have assigned the element type also along with the division into 4 elements. Now next we create a job. This was a pretty straightforward problem. So simple, create a job, name it heat transfer, and continue. We'll do a data check. So it's, see, you can see the message here has been submitted, completely successful, completed successfully, completed successfully. Now we just submit it. Ignore that warning that so yeah, here the job has been done. Now we can view the results. So yeah, again we can go to this contour plot, and yeah, so we'll first go to NT11. So NT11 here is our temperature. Okay, so how you know is that, how I understood is this blue is 100. That's what we defined as boundary condition, right? This is our point, left and side points. Rotate it. And we'll zoom it. Yeah, so this is our left hand point, 100 degrees Celsius. So on the, so it's increasing, heat is flowing from left to right, right? Again, we are not interested in this color coding, we are interested in certain points. So we'll do query, general queries node, and probe values, right? So here we are doing NT11 probing. So I'll reduce this. Yeah, so I'll provide first node. Oh, okay, change here probe to nodes. Now click on first node, click on second node. You just have to go through this entire line and then click on those highlighted numbers, 4, and 5. Yeah, yeah. So now we'll compare. So if you go to the solution, this is a solution. See, T1 is node 100, 100, 183.33, 266.667, matching perfectly, 350, 433.3, 350, 433.3. So yeah, these are answers are matching exactly same. Again, we cancel it. Something else we need to confirm? Uh, nothing else. That was our only objective. Find the temperatures at different lengths. So that is what we did.